Hello friends, myself R.D. Mahajan, Assistant Professor, MIT Armbar, presenting my next video on the topic Solution of Ordinary Differential Equation by Laplace Transform, Part 4th. First example, solve dy by dt plus 2y plus integration from 0 to t y dt is equals to sin t, and the condition y at 0 is equals to 1. Given differential equation is of first order with y as dependent, t as independent variable. Therefore, solve this by Laplace transform technique. Therefore, given differential equation as dy by dt plus 2y plus integral from 0 to t y dt is equals to sin t. We call this as equation 1. First step, taking Laplace transform. Of equation 1 means Laplace of left hand side is equals to Laplace of right hand side, and then taking individual Laplace on left hand side. Therefore, Laplace of first term dy by dt, to constant, Laplace of y, Laplace transform of integral from 0 to t y dt, and is equals to Laplace of sin t. Okay. Using this standard result, Laplace of first order derivative s y bar of s minus y of 0 plus 2 times Laplace of y is y bar of s plus Laplace of integral as per that theorem of property, it is 1 by s into y bar of s, and Laplace of sin t standard result 1 upon s square plus 1. Okay. There are 3 terms of y bar of s. Combine it. It is s plus 2 plus 1 by s into y bar of s is equals to, substitute the value of y of 0. Y of 0 is 1, therefore minus 1. If you transfer to that side, it becomes plus 1. Therefore 1 upon s square plus 1 and plus 1. Cross multiply this, we get s square plus 2s plus 1 divided by s into y bar of s. Cross multiply, find LCM. It is 1 plus s square plus 1 whole divided by s square plus 1. This is a perfect square of s plus 1 bracket square divided by s into y bar of s is equals to s square 1 plus 1, we get 2 divided by s square plus 1. Transferring this to right hand side, and therefore we get y bar of s as s square plus 2 divided by s square plus 1. When we transfer to this term to right hand side, it becomes s divided by s plus 1 square. And therefore, if you rewrite this by multiplying it inside, it is s cube plus 2s divided by s plus 1 bracket square into s square plus 1. We call this as equation 2. There are two factors in the denominator. First one is a repeated, real and repeated, and the second one is quadratic. And here degree of numerator is 3 and degree of denominator is 4. 3 less than 4 means it is proper fraction, and as it is proper fraction, we can use partial fraction technique. Therefore, finding inverse by partial fraction. Taking inverse Laplace transform of equation 2. Second part. And therefore, inverse of y bar of s, inverse Laplace of the right hand side term, it is s cube plus 2s divided by s plus 1 bracket square and s square plus 1. Using partial fraction technique or method. Okay, and therefore we have that term s cube plus 2s divided by s plus 1 whole square s square plus 1 is equals to applying that is case 2, when factors are real and repeated, it is way to write like this: a upon first factor s plus 1, as it is repeated, b upon, we increase the power by 1, therefore it is s plus 1 bracket square, and this one, second one, is a quadratic factor, therefore next is cs plus d divided by s square plus 1, and we call this as equation 3. Finding LCM of this three term is s plus 1 whole square into s square plus 1, and therefore we get s cube plus 2s is equals to, dividing by s plus 1 to this, remains s plus 1 into s square plus 1, by which we multiply to that a, therefore a into s plus 1 s square plus 1, b into, dividing by this s plus 1 whole square, get cancelled, remains s square plus 1, therefore multiplied by this to that b. cs plus d, dividing by s square plus 1, this get cancelled, therefore remains s plus 1 bracket square, multiply by that, and then simplify it. It is equals to a into multiplying term by term, it is s into s square, we get s cube plus s square and plus 1. Total 4 terms. B into s square plus 1 cs plus d, expanding it, it is s square plus 2s plus 1, and therefore it is equals to a into s cube plus s square plus s plus 1 plus b into s square plus 1, multiplying it inside, we get plus I will write down the terms of C. Therefore, s into s cube, 2s square, and s, 3 terms, plus d into s square plus 2s plus 1. Okay, and then collecting the terms of s cube, s square, s and constant term, and therefore a into s cube, c into s cube, 2 terms of s cube, then collecting the terms of s square, a into s square plus bs square plus 2c s square and plus d. Okay, then the collecting the terms of s, a into s plus cs plus 2ds and plus constant term. Constant term here is a plus b plus d, and then comparing two sides. Coefficient of s cube is here a plus c, and no term, cube of s cube is, coefficient of it is 1, therefore a plus c is equals to 1. Coefficient of s square is a plus b plus 2c plus d, and no term of s square, therefore it is equals to 0. Coefficient of s is a plus c plus 2d, and here it is 2, and the last a plus b plus d, a plus b plus d, constant term, and no constant term is here, therefore it is equals to 0. Therefore solving this equation simultaneously, therefore if we put the value of a plus b plus d is equals to 0 in this equation, it gives you, therefore a plus b plus d is 0, therefore we get 2c plus 0 is equals to 0, that gives you c equals to 0. If c is 0, we get from first a is equals to 1 minus c, it is 1 minus 0, we get 1. Okay, and using these two values in these two equations we get, and therefore substituting value of a and c, a is 1 here, c is 0, plus 2d is equals to 2, therefore 2d is equals to 2 minus 1, we get 2 minus 1 as 1, and therefore d is equals to 1 by 2. Okay. And put the value of a and d here, we get b is equals to minus a minus d. The value of a is 1 and d is 1 by 2. Minus 2 minus 1, we get minus 3 by 2. Therefore, value of a is 1, b is minus 3 by 2, c is 0, and d is 1 by 2. Substituting these values in equation 3. Therefore, equation 3 becomes s cube plus 2s. The value of a is 1. Value of b is minus 3 by 2. Value of c is 0. Therefore, this becomes 0. Plus d. D is 1 by 2 divided by s square plus 1. And then taking inverse on both sides. And therefore, inverse of left hand side s cube plus 2s divided by s plus 1 bracket square into s square plus 1, and it is equals to inverse Laplace of right hand side term. It is equals to 1 upon s plus 1, its inverse is e raised to minus t, standard result, minus 3 by 2, shifting theorem, s replaced by s plus 1, therefore it is e raised to minus t, and into inverse of 1 by s square plus 1 by 2, inverse of 1 upon s square plus 1 is sin t, and then simplifying it, it is e raised to minus t minus 3 by 2 e raised to minus t, inverse of 1 by s square is t plus 1 by 2 sin t, and the inverse of this means the inverse of y bar of s, and therefore substituting that here, inverse of y bar of s is y of t. We get this, as a required answer. Okay. Therefore, in this example, in this particular example, it is not possible for us to apply convolution method or theorem, as we don't have a product of two terms of S where to apply partial fraction method. In this combination of two cases, case number one when factors are real and repeated, and third case when factor is quadratic. Therefore, using that technique, as I have discussed in the earlier videos, we try to get the inverse by applying that two techniques. Therefore, we get the final answer as y of t is equals to e raised to minus t minus 3 by 2 e raised to minus t into t plus 1 by 2 sine t. Okay. Like this, therefore, I have discussed in detail all the examples in 4 parts. At this point, solution of ordinary differential equation by Laplace transform technique. Okay. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel for latest updates or new updates. If you have any doubt, please ask your doubt by making comment. I will try to give the answer for I will try to solve your doubts. Thank you very much.